Hi there, I just wanted to record a quick video on how we find our graph for flow. So keep in mind that flow is the derivative of volume, right? It's the rate of change of air coming in and out of the lungs. So it's the rate of change of volume. So when we go to find the derivative here, in order to find my Fi, this is Vi prime. So I have a 2000 out front and I'm going to leave that there. When we multiply by a number, and take its derivative, we leave the number there. Now, inside the parentheses, the 1 minus, the derivative is going to be 0. So then you have minus, and the derivative of e to anything is the e to the anything, so e to the negative 1.25t. And then you got to multiply by the derivative of what's inside your e. So what's inside your e is the exponent up here. So the derivative of negative 1.25t is negative 1.25. And so then you're taking those two. Now notice here that your negatives are going to cancel out. So the flow here is going to be positive for Fi. And then you're just taking 2,000 times 1.25. So that is 2,000 times 5 over 4. Let's see, that becomes 500 times 5, which is 2,500. So 2,500 e to the negative 1.25t. So if I'm going to go and graph that on my Desmos, we're going with, oh wait, it didn't delete, 2,500 times e to the parentheses negative 1.25 times x parentheses. And now we're actually going to zoom that in quite a bit. And so you get this graph as your graph for Fi. Then you need to take your VE and do the same thing. So right there's my VE. It's the 13.74 times 10 to the negative 10 times e to the, when you multiply that through, that should be 33 minus 1.25t minus 1. So now, again, when you go to find your derivative, your Fe is your VE prime. We leave the number out front. In this case, in our parentheses, we're going to take the derivative of the e first. And the derivative of e is e, so it's whatever's there. And then I multiply by the derivative of what's inside. And what's inside is this exponent here. The derivative of that is negative 1.25. And the derivative of the minus 1 is 0, so I leave that. So notice this one's going to be negative. So it's going to be negative 1.25 times 13.74 times 10 to the negative 10 times e to the 33 minus 1.25t. And you're going to put that into your Desmos as well. So it's going to look something like this. So y equals, how about not? They want something else. So let's go with z equals. And I want negative 1.25 times 13.74 times 10 to the negative 10 times e to the parentheses 33 minus 1.25 x parentheses. And go. Let's see what happens. And there it is. That's exactly what I want. And so that is my graph for flow.